Hi, I'm Jesse Tishafer, and today I am coming to you live from underneath this rock climbing wall in my basement, because where else would I film a vlog, honestly? But anyways, today I'm really excited because this is the first episode of a new video series I'm doing about the physics of music production. And I know what you're thinking right now, physics and music, how do they connect? But they actually go hand in hand, and when we learn why, it will help you become a much better music producer and really give you a deeper understanding of why things are the way they are in the music world. So for today's episode, we are going to start right at square one and talk about the physics behind sound waves themselves. We're going to learn how sound is produced and how that relates to musical instruments and how they produce their sound and make notes. So we're going to start really basic here, but don't worry because we'll move on quickly and get more involved in the music side of things and production side of things in later episodes. This is just to kind of give you a basic knowledge, and I mean everyone has to start somewhere, so let's get right to it. Sound waves are produced when the particles of a medium begin to oscillate or move back and forth at a regular speed. For example, watch this slow motion video of a tuning fork in water. The vibrating prongs of the fork move the particles of the water back and forth, creating these waves. The exact same thing happens to air particles when any sound is made, even though we can't see it. However, we can see the different parts of a sound wave through a diagram. The very tops of the waves are called the crests or peaks, while the bottoms are called the troughs. The wavelength is a measurement of distance in one complete wave cycle. The wavelength can be used to find either the time it takes for the wave to complete one cycle, also known as the period, or the frequency, which tells you the pitch of the sound wave. On the diagram of a wave, we can also label the amplitude. The higher or larger the amplitude is, the louder the sound will be. In order to understand how musical notes are made from a physics standpoint, we must first learn about interference. There are two different types of interference, constructive and destructive. Constructive interference is when the peaks and troughs of two or more sound waves occur simultaneously and thus add together, creating larger waveforms. Destructive interference happens when the peaks and troughs of the sound waves cancel out each other, creating a smaller waveform and a quieter sound, sometimes even silent. Here is a visual example of constructive and destructive interference. Obviously, multiple sound waves can line up in a variety of different ways, and the outcome will not be as perfect as is shown here, unless the two waves are lined up exactly. Interference is a very important thing to consider in music production because it can affect the whole sound of your piece. Now we're going to talk about the actual source of our music, the instruments. Instruments will create one of two different types of sound waves, standing waves or transverse waves. Standing waves are created most commonly by wind instruments, and they occur when the waves reflect and interfere with each other inside of a tube. When the sound is produced by blowing into an instrument, only the waves that can fit within the tube itself can be heard. The longest wave that can fit in the length of the tube is called the fundamental wave, while all of the other waves floating around inside the tube with it are called overtones or harmonic waves. Different frequencies of fundamental waves create different notes, and as the fundamental wave decays, you will begin to hear more of the overtones coming through. Transverse waves, on the other hand, are waves produced by string instruments. These sound waves are created in a very similar way to standing waves, except that the vibrations travel along a fixed string instead of within a tube. Several different harmonics are also produced, as you can see in this diagram. As we get further into this series, you'll see how important it is to understand how all of the basics of the physics of sound work and how they relate to instruments and music. I know there's a lot of information being thrown at you all at once, but you can rewind this video and go back and make sure you really get a thorough understanding of everything that we went over today. This will be really important in the future because, for example, when you're working in a digital audio workstation, you can actually see the sound waves on the screen. However, they don't look just like the basic diagrams that we saw today because you can actually see the overtones within each of the waves. For example, in this picture, you can see that even four very similar woodwind instruments each have very different waveforms, even though that they're all playing the same note. So that's about it as far as information goes today, but before we leave, I want to introduce you to a new segment that I'm going to be including at the end of each of my videos called Song of the Day, where I'll give you a song recommendation and hopefully you'll check it out and enjoy that song as much as I do. Okay, so the song that I recommend for today's video is Never Let Me Down Again by Depeche Mode from the album Music for the Masses. And it's actually the intro song that you heard on my video, and it will be for the remainder of the series, because I've actually been pretty obsessed with this band lately, and they have just great songs. Martin Gore is a fantastic songwriter, really catchy, awesome music. It's kind of like a 80s electronic music, really influenced a lot of today's acts actually. So I definitely recommend you check out Never Let Me Down Again by Depeche Mode, and also look into all the other stuff too, because they're pretty cool. So thank you for watching. I really appreciate the time that you took to watch this video, and hopefully you learned something along the way too. Please tune in next time to see our next video in the series. We're going to be talking about reverb and how the physics of reverb work in music production. So hopefully you'll tune in, and thanks for watching.